One of the many questions that keeps coming up is what's the difference between exponential and linear? One way, and there's a lot of ways to describe that, so I'm going to attempt to describe it in all of the ways that I can think of here. So one way to describe the difference between exponential and linear is by showing you a like story problem or in context. Usually when there's something like a percent of increase involved or a percent of decrease, that's indicating exponential. So you see here I have this problem. You start with $20 and increase by 65%. In this case, the a, an exponential equation is always written y equals a times b to the x. Put that on there. And so the a part of that stands for the beginning amount or the 0th term or beginning amount. And so in this case, a would be 20. And if you're increasing by 65%, then the b in this particular case would equal 1 plus 0.65 because 65% can be written as 0.65. So it would be 1.65. And so I could just easily write the equation y equals 20 times 1.65 to the x. So that is one way to look at an exponential problem. Now, sometimes you don't have all of that information. You might not know what A is. You might not know what B is. So let's look at a table that would define an exponential equation. So let's say that for some reason you know that the points 2, 5, and 6, 180 are on the graph of the exponential equation that you're looking for. So this is completely separate now than the one that we just talked about. It's a different problem. So I usually like to start making a table. So I know that the point 0.25 exists, so I might put 0.25 on there. And then I know that the 0.5, or I'm sorry, I don't know the 5 one, but I do know that the 0.6180 exists. I might put 6180 exists on my chart, so I'm just going to put that on there and extend my line a little bit here so that I have that on the chart. Now, I don't have A or B in this case. And remember, A we could find by taking the 0th term, which we don't have. That would be A. And B we can find because that's the multiplier. So exponential means that every time to get to the next term, you're multiplying by something. So 5 times something would give me the 3rd term. And then whatever that is times something would give me the 4th term. And then whatever answer I get there times that something, and I'm calling it B, would give me the 5th term. And then whatever that is times something would give me 180. And so I usually like to write a little equation to represent this. So I can see 5 times B times B times B times B, and another way to write that is B to the 4th, is going to equal 180. And now I just solve that for B to figure out what B is. So of course I would take 180 and I would divide that by 5. And let's see, 5 goes into 18 3 times and 36 times. So it must be B to the 4th equals 36. And then I would take the 4th root of both sides to figure out what plain old B was. And in this case, b is going to equal the fourth root of 36. So I get out my calculator, and I would do the fourth root of 36. And again, to do the fourth root, if you have a graphing calculator, you hit the 4 first, then the math key, and then the root key, and 36. So I get 2.45, about 2.45. So now I know what my multiplier is. And so b equals 2.45. So my equation is going to be y equals something, which I don't know yet, because I have to figure that out, times 2.45 to the x. And now to find out what a is, maybe I would take 5 and I would divide it by 2.45, and I would get this term, and then I divide it again by 2.45. So I'm just going to take 5 and divide it by 2.45 and divide it by 2.45. I get 0.833 about. So that's going to be my a term, 0.833. And so that would be my equation for this problem. So it's just a couple different ways that you'll see exponential. That versus linear. Linear, a story problem, instead of being a percent increase, you increase by the same amount every period. So in this case, I say you start with $20 again, still starting with $20. You're still increasing, but this time you get $100 each week. So anytime you see something that you're increasing by the same amount over the same amount of time, that is linear. And the major difference between exponential and linear is that a linear equation follows an equation that's from Algebra 1, y equals mx plus b. Or in this class, we would maybe call it y equals bx plus a, if we're going to stick with a meaning the starting amount and b being the adder. So the main difference between linear and exponential is now, instead of multiplying by a number every time, to get to the next one, you add something. So that's what linear is, you add. So 20 plus something is going to be the first term, and then that same thing plus something is going to be the 570. So now my equation is going to look slightly different, because I'm going to have 20 plus 2 b's, because plus b, so that would be 2b, equals 570. And now to solve that, that's a simple algebraic problem. I would just subtract 20 and divide by 2. So 550 divided by 2. In this case, b is 275. So y equals, and here I was given my original amount, so I'm going to say y equals 275 x plus my starting amount, which was 20. And now I can check it if I want and just see if it's right by checking it with this one. 275 times 2 plus 50 should equal 570. And it does. So that's the difference between exponential and linear.